Hello folks, welcome to another edition of Marshable Math. Today we're going to be discussing a slightly different topic. We're going to be discussing geometry, and in particular geometric constructions. You may have heard me talk about the quadrivium before. I'm not sure which order you're watching the videos in, but the quadrivium is the four mathematical arts of the seven liberal arts. The first three are language based. They are grammar, logic, and rhetoric. But the last four are the mathematical arts. And in reading Introduction to Arithmetic by Nicomachus, who is an ancient mathematician, he gives these definitions here for these four mathematical arts. The first one, he says arithmetic is absolute quantity, and by that he means the properties of the numbers in relationship to themselves only, right? So what is a prime number? What do you get when you multiply an odd number by an even number? Those sorts of things. Next he says music is the next one on the mathematical arts. Now you think about it, and you think, wait a second, music? Is that a mathematical art? Well, yes it is. He defines music as relative quantity. Quantities in relation to each other. So it's not the individual value itself that's important here, it's in the relationship of the values to themselves. And if you've ever studied music in a sense of sound, you know about harmonic ratios and so forth. The ancient idea of music encompassed more than that, but not to spend too much time on this. He then says geometry is size at rest. Notice there's a change here. The first two talk about quantity. The question being answered is how many. Here we're talking about size. The last two deal with size. So geometry, he says, is size at rest. What is space? Space at rest. And the last one he says is astronomy. That would be size and motion, because they would look up into the heavens and they would see these different shapes and so forth, and they would be in motion around each other. So that would be the four mathematical arts. Nicomachus actually says you should study them in this order, that you can't get to music until you've done arithmetic, and you can't get to geometry until you've done both arithmetic and music. But today we're going to focus on geometry. Geometry, we're really talking about space. We're talking about sizes and the shapes of things. Okay, so the primary tools of the geometer would really be the compass and the straight edge, because what they're doing with these things is they are working with sizes. A straight edge allows them to draw a straight line, and a compass allows them to draw a perfect circle. Before they actually started to ascribe number values to shapes, they first studied the shapes themselves. So we're going to study constructions today. And constructions has a rather particular sort of a definition, or a restriction you might say. It's accurately and precisely drawing geometric figures using only a straight edge and a compass. Okay, so the classical Greeks, when they first started to develop geometry then as a discipline, recognized that geometry depended upon understanding of points, lines, shapes, and so forth in physical space, and then they started to abstract these to the perfect ideal. You never can draw a perfect circle in the world, but you can consider its properties perfectly. So they began by studying the spatial relationships of figures, and the tools that they used were spatial tools: a straight edge for connecting points to make lines, and a compass for creating circles and arcs of circles. So the only two tools that you really need are a compass and a straight edge. Wait, compass, straight edge. There we go. Whoops. Can't have the numbers on there. Straight edge. Alright, so straight edge. Any tool that really will allow you to draw a straight line. I've even had students that, out of desperation, used another pencil. Because, a pencil has a pretty straight edge there. You could use a pencil as a straight edge. So it could be anything. In most cases, we're going to use a ruler, since that's the most commonly available one. But you can't use the markings on the ruler, because this is kind of an abstract insertion of quantity on a ruler. I'm not really precisely sure that these things are correct. Anytime you take a measurement, there's some degree of uncertainty. All we wanted to do, though, is use a straight edge to draw a straight line. So let's use the back side of the straight edge when we can. And a compass. Before we get to a compass, let's talk real quick about a circle. A circle is, by definition, the collection of all solution points, or the collection of all points that are equidistant from a center. So I'm going to draw a circle here really quickly, and all I'm going to use here really is a piece of string. So watch me. It's magic. I'm going to take my marker, and I'm going to make a center point, say here, and then I'm going to put my finger on that point, and I'm just going to then draw hopefully is a another perfect circle. Notice if I keep the marker in the little loop here, it controls the distance that the marker is from the center. It got a little corny as I went around the corner there, but there you go. So it's the collection of all points in a plane that are equidistant from a fixed point called the center. So this point over here is the same distance from the center as, say, any other point on the circle, this point right here. Usually, though, you won't be using a piece of string. You can if you have to, but most of the time you're going to be using a compass. Okay, compass is used for drawing circles and arcs. It's made of two legs and a means of adjusting the distance between the ends of the legs. At one end of the leg, you have a sharp little point, which we're going to call a spike, so that we don't confuse it with the geometric idea of a point meaning location, like a point on the circle here. We'll call the sharp little end the spike, and the other end will usually have a pencil lead. Now, I got a word of warning here. I really recommend that you get yourself what's called a bow compass, which has got a little crossbar here with a screw and a nut, and by spinning the nut, you can open or close the legs of the compass. I really don't recommend that you get this kind of a compass that you would buy at, say, like the grocery store. It'll work if you have to, but the problem with this is it's got a clamp here that holds these pieces together by friction. And so all you have to do to open it or close it is just to pull on it. Well, the key point here is that you want to keep the distance between the spike and the pencil lead the same while you're drawing the circle. That's really the radius of the circle, right? The distance here between the center and the circle edge is the radius. You put your spike on the center and your pencil here on the thing, and as you spin it around, you don't want it to change. But over time, these things can become very, very loose, and as you're drawing a circle, I've seen many, many students that have had them slip on them or open up, and they just don't stay put. So I really don't recommend this. Bow compass would be the one that I'm referring to today. Okay, moving on. Have I covered everything? I think I have. Let's do a little bit of practice. Okay? You might think, well, gee, it's really not that hard to draw a straight line from 2 points, but there's a particular technique that you would need in doing it. Let's go to the blank screen here. All right, so let's suppose I had this location here in space, this point, and I had this point right here, and I want to draw a straight line between them. So I'm going to use my straight edge. But if you try this first before following my little directions here, you might notice that you'll miss a little bit. Theoretically, a point has no width. It's dimensionless. So even though I've drawn it on the board, and here I'll exaggerate, here's a big fat point. But really, in theory, it's the center of this. And so if I were to draw a line that goes through here, just kind of like, oh, I'll put my ruler up there and so forth, and make sure that the edge of the ruler goes through the middle of these 2 points, and then I'll draw my line. And if you'll notice here, it kind of sits a little high, right? The line itself sits a little high. That's because there's some thickness to your tool, whatever you're using, a pencil or marker or pen or whatever it is. There's some thickness to that. So there's a technique in how we might do this. And I missed. It's got to go through the exact center, and you need to be precise. If you've ever drawn lines between grid marks on a piece of graph paper, you know sometimes it's very hard to hit that exact center. So here's what I recommend that you do. First of all, put your instrument on the point itself first. Find the exact center. And then I would take the straight edge, and this is a little awkward to do on the board here, I'm sorry, it's a little easier on your paper, but bear with me here. If I put well, let's do it on the underside because of the shadow. If I put it here, then without moving my instrument, I'm going to slide the straight edge up to it and put it against the instrument. In my case, it's a pen. Notice that it doesn't sit, the edge of the straight edge doesn't sit right on the center of the circle. That's because there's some thickness to the marker here that's taking up that space, and I have to account for that then when I draw the line. So marker in the middle, ruler up against the marker, and then notice the offset between the center of the point and the edge of the ruler, and then without removing the ruler from the marker, I'm going to angle it over so I get an exact kind of a duplicate of the space. Does that look like it's about the same? It kind of does. Whoops, it kind of does to me here. And then I'm going to draw my point. It slipped a little bit through. That's much, much better. Okay, so pencil point on the point itself, slide your ruler up against it, angle the ruler then, still in contact with your pencil, to the next point, and make the same spacing arrangement on the second point as you have on the first, so that when you draw your line, it goes through the exact center of the point. Okay, that's not too hard. For circles, I'm going to do all my circles on the board with my super duper fancy smanchy string, because, do I even have it out? I don't think I have it out. Pardon me a second, my planning has gone awry here. I've got a whiteboard compass. Oh, stink bomb, I can't find it. Maybe that's because I threw it out and finally got tired of it. One last look. Oh, yeah, oh, I did find it. Rats. Maybe I'll throw it up tonight. This is my compass, right? So hey, spend about 40 bucks for this puppy. Yeah, it's got a suction cup here in the end, and it's got a little rubber thing here in the board. And what I do is I open this up, I stick the marker in there, and it clamps it on. And then I get up here and I'm it doesn't work very well at all. It opens up, the marker scoots back in here, this thing slides off the point. It's really a pain. So I'll do that. I'll just use a string. Okay. My advice when you do your compass practice here, the spike is going to go at the center, and then you open it up so that the pencil lead then will draw the circle. The natural habit is to kind of grab this thing by both legs and go, and draw your circle like that. That's really awkward, and it probably won't turn out very well. You want to minimize the contact that you have with the compass if at all possible. You want to influence it as little as possible with your body motions, because you'll bump it or you'll pull it the wrong way, and it just really doesn't turn out very well. So notice up here at the top there's like a little stud. That's where you should hold the compass. Not even in the middle with one hand here like this and twist it, because if I twist it like this, notice both legs are twisting. I really don't want that. I want one leg to be fixed, and I want the other one to spin. So if you hold it right at the top, put your center down, and then you spin it, almost like you're twirling a top or something like that. That's how you would use the compass. And sometimes it's even beneficial to not keep it rigidly straight up and down, but maybe lay it at an angle and kind of swoop it around like so. I don't know if you can see that on the video with us here or not, but on the graphic I showed you just a second ago, I hope to capture that ideal here, right? See, here we've got the compass, and it's being leaned down, and it's being, I'm making a sweep here as I go around. So I'm kind of moving my hand in a circle, but I'm also spinning that little stud at the top. It takes some practice. Find your technique. If you just want to pause the video for a minute and make a whole page or two, bunches of circles, that'd be great, okay? You should first practice with the tool before you try to do something with it. So just like a painter might, instead of taking a paint and brush, and I'm going to try this new stuff out and trying to paint something, he'll just piddle, right? Just make marks on the canvas, just getting the feel of the tool. So if you want to, go ahead and do that. And if you're back, notice here the straight edge, the pencil point on the point, the straight edge on the pencil, and notice the edge of the straight edge doesn't go through the center of the point, but because of the width of the pencil itself, when you draw the line, it'll go through the middle. Okay? Are you ready to do some constructions? I feel like I've been talking for an hour. We haven't really got anywhere yet. But anyway, moving on. Number one, how do we reproduce, add, subtract, or find multiples of line segments? Hey, I've got this line segment here, AB. Redraw it over here. Exactly the same length. Well, what the straight edge allows you to do is the straight edge allows you to draw a straight line, and the thing that controls the length is your compass. The distance between these 2 points, your spike and your pencil tip, oh, that's the bad one. The distance between these 2 points, the spike and your pencil tip, that is your controlling of the distance. This distance then is what you keep the same, or change if the case may be. So here's what I'm going to do. If I want to reproduce this line segment, I'm going to draw another line, and I'm going to make it longer than the first. And I'm going to come over here and I'm going to reproduce this point here. If this is A, I'm going to call this A with a little, I don't know, apostrophe or a little mark above it. That's called like A prime. Sometimes that means it's an image of A, or it's like a reproduction of A. So I'm going to reproduce this over here. It's not exactly the same location though, so I have to give it a slightly different name. So I've got my location of A corresponds with this location of A. Now what I want to do is I want to control the length between this point and that point. So I'm going to use, will my string even reach? I didn't think about that. It won't. Well, it's too late to stop the video. Let me see if I can't find my other string. Maybe the ooh, I found one. It's not pink though. String it? Okay. Had that pink string for years. Let me do another one. Sorry, we're having technical difficulties. Please stand by. This is embarrassing. Okay, so here we go. I'm going to use my compass now to extend my pencil point right out so that when I hold my center at A, nope, that's too short. It goes out to B. Maybe I'll even make a little mark right there. You see how my distance now between my finger here over here at A and the marker here at B is exactly what it needs to be? Without changing it, I'm going to come over here, make a little sweep, and that's my B prime. Now, were I doing it with the compass, it would look like this. So I would open, I put the spike on A, and I would open my compass up exactly to B there, and then without changing the distance, I would come over here and then do my sweep. So this distance right here, A prime to B prime, is the same distance as A to B. So that's how I would then reproduce it. What if I wanted to do a multiple of it? Well, I don't want AB, I want 2AB. It should be very obvious to you that if you simply do it twice, I'll extend this line out here. I hope it still sits in the video frame. I think I got a little margin over here. It should still be the same. So if I come over and if I do 1 A to B, and then I'll do a second one, that should give me double. So there's one here, and then I come over here and do it a second time. If you can find that, then that whole distance there is 2AB. Okay, so that's how you would do multiples. If you wanted to add two segments together, let's say that I had another segment that was maybe a little bit shorter. So like that one, CD, how would I add these two things together? Well, I would mark off AB, and then I would take a CD and add it to it, and that would be a sum. If you wanted to do a difference, you could then take the CD off of the end of B and mark it like back over here, and then this would cancel, and then from the one point to the end, maybe I'll do that once. So that's a little too confusing to do it just in theory. So if I want CD, if I want to do AB minus CD, find their difference here. Let me get my distance of CD. And then, okay, maybe I'll just do it here on this end since it's going to the right. This distance right here would be C to D. And if it's AB minus CD, then this all cancels. And then this distance right here is what I've got. That's my difference. So there's lots of different things that you can do with this. Line segments are pretty easy. All right, let's move on to the next one. Constructing circles of a given radius. This is fairly straightforward, okay? All I'm going to do then is take my compass and open it up so that I've got my spike on one end and my pencil tip on the other, and then just draw a circle. So what if I want a circle with a center at A and a radius of AB? Extremely easy. Open up your compass, spike at A, pencil point at B, and then draw yourself your arc. Okay, there you go. And again, this is the radius here. If you wanted to do a different one, like I've got a second one over here, I was going to have the circle centered at B and the radius at A, but you get the idea. I'm not sure that I need to do that one. And again, if you're using a regular compass, you would spike at A, pencil at B, and then you would then do your sweep, obviously one-handed. It's not easy, is it? You may be struggling at home. It's okay, it takes practice. So we can reproduce lines, we can reproduce circles. Let's keep moving. Reproducing an angle. Ooh, that's challenging. An angle is the rotational separation of two rays. You got a ray that starts at B and goes out through C, a ray that starts at B and goes out through A. And what is the rotation, what's the separation rotationally between these two rays? Well, here's what we're going to do. So if I want to reproduce this, I'm going to draw another line. Make it longer. I'm going to pick a point, call it B prime. Now, here's what I'm going to do. The compass, remember, allows me to control length. So what I'm going to do is I'm going to draw not a whole circle, I'm just going to draw an arc. And really, all I need is I need the locations where the arc crosses the lines. So it doesn't matter where, it doesn't have to be through the points or anything, but once you do it over here, you can't change it to move over there. So let me put the spike here at B, and I'm just going to draw an arc, like so, and then without changing it, I'm going to reproduce it over there. All I really need is this little location here and this little location here, but just draw the whole thing. Now, what I will need to do, and I have to show you this with the compass, what I'm going to need to do is I'm going to need to find the distance between this location and that location right there. So I'm going to put my spike at the point where it crosses, the arc crosses the base here, and I'm going to open it up exactly to where the pencil point would cross. Oops, it slipped. See what I mean? The pencil point would cross right here. Okay? I'm controlling this distance now. I know that the distance from B to this arc must be the same as the distance from B to this arc. So the distance is here, here to there, and also here to some unknown place there. If I can reproduce this distance right here, where it crosses right there, I'll find my angle. So let me see if I can do this with the real compass here. So I'm going to put the spike there. I'm going to, oh, see that's a little high? So I'm going to come in a little bit. It's a little low. This is not a good tool. Right there maybe? Okay, now reproduce it over here. Like that. Now draw your line. This point here. Down, rotate, through. There we go. Look the same? Should be. Reproducing an angle. That's one of the easier ones. Just wait to get better. Okay, next. Bisecting a line segment. Remember, bisection means to cut in half. So what we want to do is we want to find the spot here in the middle that cuts it into two equal pieces. Well, here's what I'm going to do. I'm going to take my compass now, and I'm going to open it up more than halfway. Doesn't matter how far, just can't be all the way, but more than halfway. And so, that looks like about more than halfway. And I'm going to come up here, and I'm going to draw an arc above. And without changing it, I'm going to draw an arc down below. And then without changing the distance, I'm going to do the same thing over here with the spike on B. An arc above and an arc down below. Oops, it slipped a bit. Rats, I'm going to go redo this now. So, here. Yeah, see, that's the one I want. If you're using a compass, it would look like this. You would open your compass up more than halfway. You would then put the spike at A, and you would do a sweep above and a sweep below, and then without changing the opening, come over and put your spike at B, and also do a sweep above and a sweep below. What I do now is that I take and I connect these 2 points. Down. I've got this situation right here. This location right there, if done properly, should be the midpoint. Interestingly enough, it also makes a perpendicular line. I want you to think about why for a second. Why would it do that? What I've done by controlling the distance is I've actually made, without drawing all the pieces, is I've made a rhombus. Rhombus is a quadrilateral with 4 sides that are equal. The angles don't have to be equal. 4 equal sides and equal angles, that would be a square. Maybe this one actually looks like a square, I don't know. That would be accidental. But what I've done is I've made a rhombus here. And one of the properties of a rhombus is that the diagonals here from the corner, they bisect each other. So by using the compass then to control the length, I have then made 4 sides equal. The diagonals then must bisect each other. This must be the midpoint. Ordinarily you wouldn't need that. I'm just giving that to you extra as, so that you understand what we're doing here. And actually I wouldn't even need any of this. All I would really need to do the midpoint would be just simply to find the location there that cuts it into 2 equal pieces. So that would be bisecting a line segment. Okay. Next one, bisecting an angle. This one's curious. I like this one. How do I cut this angle in half? How do I find a ray that goes through the middle so that the angle here is split into 2 equal angles? Okay, again, compass. You're going to draw an arc. Anywhere with a spike at the vertex here. Draw an arc. Okay. Now, you're going to move your spike up to these 2 locations right there. And it doesn't even have to be the same distance. You can change the distance. Here, I'll change it. I'll make it a little bit longer. So I'm going to draw an arc here. And then without changing it, I'm going to draw another arc here. Ooh, almost missed it there. Sometimes you got to draw them a little longer than you thought. And this now is the point that I'm interested in. If I take that point, and if I draw it into the vertex, I'll have my ray that will then cut this angle into 2 equal pieces. Like that. So this is the line that bisects the angle. So again, if you're working with a compass, let me recap. Take any old arc, make your sweeps, and then move your spike up to where the arc intersects the first ray. You can keep it the same distance, but I open it up just to show you that you can have to. Okay. Make an arc here, and then without changing the opening, move to the other ray and make your arc there. Where those intersect, draw it into the vertex. You've just bisected the angle. What you've done is you've made a kite. Like this. See, it's not a rhombus quite say, but it's a kite. So it's something that looks like that, right? So you got your string and, oops, no, the string's supposed to be straight, right? Like this. Here's Ben Franklin.